Now, I do want to make one comment here. I've condensed the two logs into one. It is very tempting to knock out this log with this log, but we cannot because the bases do not match. Even if these bases did match, we still couldn't knock out these logs because that is ruining things. But it doesn't really matter because for this exercise, you know what we can do? We can type in all of that into here, because unlike this, which has variables, this has just numbers. So I'm gonna type it in here. And if I get back something nice, I'm gonna put that number here instead. Now, this type of problem does require some trial and error. You see, we have 10 over 21. But the problem is, to create a 10, you could think of 2 times 5. But I have a 5 here, but I nowhere have a 2. So what you have to do is a little bit of experimentation. What if I multiply this fraction top and bottom by the number 2? I'd get 20 over 42. Is there a way that I could use a 6, a 5, or a 14, or an 8 to make a 20? I don't think so. So instead of multiplying top and bottom by 2, let's try top and bottom by 3. That would be 30 times that by 3, I get 63. Is there a way to take these numbers and to multiply them to create a 30? Sure, I could think of 6 times 5, but how would you create a 63? So let's try something else. What about multiplying top and bottom by 4? You multiply that by 4, you multiply this by 4, and I think this works because for 40, we have an 8 and a 5. For 84, we have 6 times 14. So what I'm gonna do is I'm gonna multiply this top and bottom, times it top and bottom by 4. That turns it into 40 over 84. Now for the 40, break it up into 10. No, what was it? It was 8. 8 times 5 is 40. And for 84, we could use 6 times 14. And now let's use the expansion properties. And for log base 6 of 8, we have r plus. For log 6 of 5, we have q minus. For log 6, it's not listed, but we know that log base 6 of 6 is 1 minus log 614 is p. So we have r plus q minus p minus 1. The order doesn't matter. I'll turn that in. Okay, let's do one more. Here we have the graph. So recall what you always do is first you have to find C. So for that, you set your argument equal to 0. That is your C value, but that is a weird number. I do need a decimal because I have to graph this. So our C value is about 3.3, which means I can go to 1, 2, 3.3, about right there. And that would be my asymptote. Now, is this case 1 or is this case 2? To make that decision, recall, you find x and you look at the number attached to x, this number, which happens to be negative. Since that's the case, we have case 2. So the graph is going to open to the left, which means that if I open a table of values, it should be called xg of x. For a table of values, pick numbers that are smaller than c. So what's smaller than 3.3? How about just 3, 2, 1, 0? And I'll spread out the last one. Let's go -5. Now let's go Casio to fill out this column here. And now we can plot these points. So the graph should look something to this effect. Put your arrows and call the graph what it should be called. Something like this will suffice.